For basically all of human history, we've shared this planet with millions of other species. Each one has its own language, its own way of communicating. We can hear their calls, sure, but what are they really saying? Well, today we're going to look at how a new way of AI isn't just trying to listen in, it's actually building entire virtual worlds to find out.
Okay, just think about this for a second. I want you to imagine not just seeing the planet from above, but being able to zoom in on any ecosystem, a forest, an ocean, and actually understand the conversations that are happening there right now. That is the incredible, breathtaking ambition we're talking about today. But, before we can get to that amazing future, we really have to get a handle on the problem we're trying to solve. For centuries, we've been trying to eavesdrop on nature, and let's just say it's been, a real challenge.
For the longest time, our approach was super manual. Picture a researcher in a field with a pair of binoculars and a notebook. It was slow, it was subjective, and it was just about impossible to scale up. But today, the whole problem has completely flipped on its head. Now, we're literally drowning in this massive flood of data coming from sensors all over the world. So the challenge isn't about gathering the info anymore. It's about making sense of the overwhelming amount we already have.
And that's where artificial intelligence comes in. To have any hope of sifting through this data avalanche, we need a tool that can think at a scale that we humans, we just can't.
So let me introduce you to WAVE, which stands for the Wild Animal Voice Engine. Think of it as this incredibly powerful AI platform built specifically to analyze animal sounds and behaviors. Its whole job is to find those hidden patterns, those secret correlations in all that acoustic data, and make this super complex research accessible to anyone who's curious.
So how does an AI like WAVE actually hear something? Well, it doesn't just pick up a single node or a simple chirp. No, it uses this really cool technique called high-dimensional trajectories. It basically maps the entire journey of a sound across dozens of features all at once, things like pitch and timing and intensity. It's like seeing the full, complex arc of a sentence instead of just spotting individual words. And that lets the AI understand much, much deeper communicative patterns.
Okay, but here's the catch. Sound, all on its own, isn't enough, not even close. Communication is so much more than just making noises. Turns out, there's a huge piece of the puzzle we've been missing.
And this is so important. A vocalization, a sound, is just a single data point. To have any chance of understanding what it actually means, you need context. Just think about it in human terms. The word hey can mean a million different things, right? Is someone waving hello? Are they trying to warn you of danger? Are they just trying to get your attention? Without context, the sound is basically meaningless.
And this slide right here, it shows you exactly how we get that context. We layer all these different types of data together in what's called a multimodal approach. You can see we're combining acoustic data from things like hydrophones with movement data from GPS trackers, visual data from drones and camera traps, and even physiological data from wearable sensors. Every single layer adds a crucial new dimension to what we can understand.
And the sheer scale of this contextual data it's just staggering. A platform called MoveBank alone has over 10 billion, that's billion with a B, animal location data points. We have this entire universe of spatial information just sitting there, ready for us to connect it to the sounds and finally give them real meaning.
Okay, so we've got the sounds, we've got the context. Now for the really cool part. This is where we take the next giant leap, where we move beyond just analyzing data from the past and we start simulating entire worlds. The key that unlocks this incredible new door is a concept called spatial intelligence. Now, this isn't just about knowing where an animal is. It's about an AI being able to truly understand a 3D environment and reason about how everything in it, the animals, the landscape, the weather, all interacts with each other over time. That over time part is the fourth dimension. It's about understanding the space and the living physics of that space.
And this isn't some far-off sci-fi theory. This is being built right now using some really powerful new data sets. You see two great examples here. SpatialVID gives us the raw materials to reconstruct 4D scenes from video. You could think of that as the blueprint for building the virtual world. And then you have Sekai, which is all about exploring that world. It teaches the AI how to simulate an animal actually moving through and interacting with its environment. These are the literal building blocks for our virtual habitats.
This slide really just nails the whole paradigm shift. We started by simply analyzing audio, just asking, hey, what was that sound? Then we added location data and we started asking, okay, where and when did that sound happen? But now, with 4D world simulation, we can start asking something totally different, something predictive. Given this environment and these animals, what could happen next here?
We're moving from just observing the past to simulating potential futures.
So, where is all of this headed? What's the ultimate goal here? What's the end game? This quote from the research just sums up the vision perfectly. By combining the powerful sound translation engine with these new spatial computing frameworks, you could eventually allow researchers to literally immerse themselves, to step inside a four-dimensional virtual habitat and observe animal life as if they were actually there.
I mean, just imagine it. Inside these virtual worlds, the possibilities are incredible. We could literally watch how communication systems evolve over generations. We could simulate how a pod of whales navigates the noisy, complex soundscape of a modern ocean. We can model exactly how climate change or human activity impacts their behavior. This isn't just a new research tool, it's a whole new window into their world, and it could be an incredibly powerful asset for conservation.
And all of this brings us back to one huge final question. For the first time, we're on the verge of not just listening to the animal kingdom, but actually understanding the world from their perspective. So if we can truly simulate their reality, what will we finally learn about them? And maybe, just maybe, what will we learn about ourselves in the process?